Hello and welcome back to Bluehat Cybersec Academy. In this lesson, I am going to explain the following topics. Configuration management overview, the risks of change management components, and last but not the least, change management component workplace. These topics are part of Domain 5, Security Operations Concepts in the Certified in Cybersecurity exam, and are useful for both exam preparation and building a strong cybersecurity foundation. So, let's begin. Configuration management is a process and discipline used to ensure that the only changes made to a system are those that have been authorized and validated. It is both a decision-making process and a set of control processes. If we look closer at this definition, the basic configuration management process includes components such as identification, baselines, updates, and patches. Now let's move on to the first component, which is identification. Identification involves the baseline identification of a system and all its components, interfaces, and documentation. Next, we move into change control. Change control is an update process for requesting changes to a baseline by making changes to one or more components within that baseline. It includes a review and approval process for all changes, including updates and patches. Another important concept is the baseline itself. A security baseline is a minimum level of protection that can be used as a reference point. Baselines provide a way to ensure that updates to technology and architectures are subjected to the minimum understood and acceptable level of security requirements. Now let's look at verification and audit. Verification and audit involve a regression and validation process, which may include testing and analysis, to verify that nothing in the system was broken by a newly applied set of changes. An audit process can validate that the currently in-use baseline matches the sum total of its initial baseline, plus all approved changes applied in sequence. Inventory. Now let's move further into asset management by discussing inventory. Making an inventory, catalog, or registry of all the information assets that the organization is aware of, whether they already exist, or there is a wish list or need to create or acquire them, is the first step in any asset management process. It requires locating and identifying all assets of interest, including, and especially, information assets. You can't protect what you don't know you have. It becomes even more challenging to keep that inventory, along with its health and status, regarding updates and patches, consistent and current on a day-to-day basis. It is quite challenging to identify every physical host and endpoint, let alone gather data from all of them. Now let's take a closer look at baselines in more detail. A commercial software product, for example, might have thousands of individual modules, processes, parameters, initialization files, or other elements. If any one of them is missing, the system cannot function correctly. The baseline is a total inventory of all the system's components, including hardware, software, data, administrative controls, documentation, and user instructions. Once controls are in place to mitigate risks, the baselines can be referenced. All further comparisons and development are measured against these baselines. When protecting assets, baselines can be particularly helpful in achieving a minimal protection level based on asset value. If assets have been classified based on value, and meaningful baselines have been established for each classification level, organizations can conform to the minimum required levels. For example, if classifications such as high, medium, and low are used, baselines can be developed for each classification to provide the minimum level of security required. Let's now move on to updates. Repairs, maintenance actions, and updates are frequently required across almost all levels of system elements, from basic IT infrastructure through operating systems, application platforms, networks, and user interfaces. These modifications must be acceptance tested to verify that newly installed or repaired functionality works as required. They must also be regression tested to ensure that the modifications did not introduce other erroneous or unexpected behaviors into the system. Ongoing security assessment and evaluation testing determine whether the system that passed acceptance testing remains secure over time. Now let's discuss patch management. Patch management primarily applies to software and hardware devices that are subject to regular modification. A patch is an update, upgrade, or modification to a system or component, often needed to address vulnerabilities or improve functionality. The challenge for security professionals is maintaining patches, as they can arrive at irregular intervals from many different vendors. Some patches are critical and should be deployed quickly, while others may be less critical, but still necessary because future patches may depend on them. Standards such as PCI DSS require organizations to deploy security patches within a specified time frame. However, there are issues associated with patching. Many organizations have been affected by flawed patches from reputable vendors that negatively impacted system functionality. As a result, patches should be tested before being deployed across the organization. This testing is often complicated by the lack of an environment that closely matches production. Few organizations have the budget to maintain a test environment that is an exact copy of production. There is always a risk that not everything will be tested, and issues may arise in production that were not apparent during testing. To the extent possible, patches should be tested to ensure they will work correctly in production. If a patch does not work or causes unacceptable effects, it may be necessary to roll back to a previous, pre-patch state. Typically, rollback criteria are documented in advance and automatically executed when those criteria are met. Many vendors offer patch management solutions that include automated or unattended updates, allowing systems to be patched without administrator interaction. The risk of unattended patching must be weighed against the risk of leaving systems unpatched. Automated patching may result in unscheduled outages when systems are taken offline or rebooted as part of the patching process. Now, let's shift our focus to the risks associated with change. Organizations must ensure they have a robust change management process and that testing occurs in model environments before any change is made in a production or live environment. Even with extensive planning and testing, unintended consequences can occur, which is why a rollback plan is essential. A rollback involves restoring a system to the state it was in before a change was made, returning it to a known, stable, and properly functioning condition. Before introducing changes into an environment, organizations must review and test all patches and ensure they can restore the previous configuration if necessary. Maintaining a separate testing environment can be a logistical challenge for many organizations. Many do not have separate production and testing environments to properly evaluate all patches and system updates. In such cases, organizations may rely on vendor or third-party testing to certify new software releases using generic datasets. While rollback planning is important in all environments, it is absolutely critical for organizations that cannot fully test changes prior to deployment. Now let's move on to the core components of change management. The change management process includes components. Documentation is one of the most important components. All major change management practices address a common set of core activities that begin with a request for change, or RFC, and move through development and testing stages until the change is released to end users. Each step is subject to formalized management and decision-making, and each produces accounting or log entries to document results. Next is approval. Approval processes typically include evaluating RFCs for completeness, assigning them to the appropriate authorization process based on risk and organizational practices, conducting stakeholder reviews, identifying and allocating resources, approving or rejecting changes, and documenting those decisions. Another critical component is rollback. Depending on the nature of the change, various activities may be required, including scheduling the change, testing it, verifying rollback procedures, implementing the change, evaluating its effectiveness, and documenting the results in the production environment. Rollback authority is generally defined in the rollback plan and may be executed immediately or scheduled as a subsequent change if monitoring indicates inadequate performance. Finally, let's examine how change management functions in the workplace. Change management operates as a continuous cycle with no real stopping point, requiring ongoing monitoring of the environment. Any requested change must go through appropriate approvals, and the organization must always be prepared to roll back if necessary. If a change does not work as expected, the organization must be able to revert to the legacy system. While change management is an organization-wide process, it often falls to information security professionals to coordinate efforts and provide oversight and governance, depending on organizational size. In some organizations, it may fall under IT or development departments, particularly where quality or risk management teams exist. The common theme across all organizations is that change management incorporates input from end users, IT, development, information security, and management. This ensures that all changes are properly tested, approved, communicated, and implemented in a controlled and effective manner. That's all for now. Thanks for tuning in. Keep the momentum going by checking out the next video in this series. And if you haven't already, please like, share, and subscribe to Bluehat Cybersec Academy.